For the following equations, find the center, foci, and vertices of the ellipse. Then determine the length of the major and minor axes and sketch the graph. So here we have the equation for our shifted graph. X minus 2 all squared over 9 plus y minus 1 all squared over 4 equals 1. Now this is the equation of a horizontal ellipse because the bigger number, 9, is under x, so it runs longer along the x-axis. And the basic form of a shifted ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So first thing we should do is find the center. And the center is h and k. In this case, 2 and 1. So center is 2, 1. It's always the opposite of the sign that's in front of it anyway. So 2, 1. Now with the center, we can figure out what the vertices and foci are much easier. So let's move on to the vertices. So V for vertice. Now we know when it's centered at the origin, it's just plus or minus a comma 0. And a in this case is the square root of 9, a equals 3, and this b is the square root of 4, so b equals 2. So normally the vertices would be at plus or minus 3, 0. But remember, we have shifted. And the best way to know how we shifted is to look at the center. Since it's no longer at the origin, it's at 2 and 1. So it's shifted 2 positive on the x-axis and 1 positive on the y-axis. And since we have 2 vertices, we need to break it up into 2 separate points. So we're going to have a negative 3, 0 and a positive 3, 0. And now we're going to add 2 and 1 and 2 and 1 to both. So plus 2 plus 1. So we're going to have a vertice at negative 1, 1, and then plus 2 plus 1. We're going to have another vertice at 5, 1. So we have 2 vertices at negative 1, 1 and at 5, 1. So I will graph those now just to get them out of the way. So negative 1, 1 here, and then 1, 2, 3, 4, 5, 1 here. Now I'm going to find the foci. I abbreviate it F. And again, the foci in general when centered at 0 is plus or minus c, 0. And the only way to get c is to use the equation c squared equals a squared plus, minus, don't make that mistake, minus b squared. And so c squared equals 9 minus 4. So c is going to equal, that's more like an e, so c is going to equal plus or minus the square root of 5. So normally we would be having foci at plus or minus square root of 5, 0. But again, because we have shifted by the center of 2 and 1, we're going to add 2 to the root 5 and add 1 to the 0. Because it's a root 5, we don't need to actually do what we did, have 2 separate points. We can just write it as 1 point plus or minus root 5 plus 2, 1. So this is the 2 points of the foci. A positive root 5 plus 2, 1, and a negative root 5 plus 2, 1. Now we can find the length of the major and minor axes. So major axis is still going to be 2 times a. So 2 times 3 equals 6. And in the minor axis, it's going to be 2 times b, so 2 times 2, which is 4. And if you want to, you can even find the eccentricity of this. Shifted, it doesn't really make a difference. The eccentricity is still going to be c over a. In this case, our eccentricity, I'll put over here since I run out of room. C over A is going to end up being square root of 5 over 3. Now that we have all the information, we can actually go in and graph this. And so we know our center is at 2, 1. So right here. And the last thing is we need to know how the minor axis works. In that case, we can just follow along with B, which means from the center, we're going to go up to here. And then from the center, we're going to go down to here. And then we just connect the dots along the outside, like so. And there is your center, vertices, foci, major minor axis length, and eccentricity with the graph. Next we have this ellipse, x squared over 9 plus y plus 5 squared over 25 equals 1. This is going to follow the exact same thing. This is a vertical ellipse because the bigger number is under the y. And the form of that is again going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. In this case, a is going to equal 5 and b is going to equal 3. Center again is h and k. In this case, there is no h, so that means the center x value is going to be 0, whereas the k value plus 5 is going to be a minus 5. Again, it's the opposite sign. So there is the center for this ellipse. Now we're going to find the vertice, which is, again, when you centered at 0, is 0, comma, plus minus a. And since we know a is 5, very easy, we can see that it should be, if centered at 0, plus minus 5. But again, the ellipse has been shifted because the center is no longer 0, 0, it's at 0, negative 5. So what we're going to do is have our 2 points, 0, comma, negative 5, and 0, comma, positive 5. And we don't really need to add 0 to anything because 0 doesn't do much, but we can add negative 5 to both. So we can minus 5 here and get a new vertice of 0, comma, negative 10, and subtract 5 here, and we're going to get 0, comma, 0. So we will have our 2 vertices at these 2 points. Foci, same thing, 0, comma, plus minus c. And the way we get c is from the same formula, so c squared equals a squared minus b squared. So we're going to have c squared equals 25 minus 9, and c is going to give us plus minus 4. So our foci, normally centered at 0, 0, or sorry, at 0 plus minus c, is going to be at 0 plus minus 4, but again we've shifted by negative 5. So that means we are going to have 0, comma, negative 4, and 0, comma, positive 4, and we're going to subtract 5 from both. So we're going to end up with foci at 0, comma, negative 9 and at 0, comma, negative 1. So these are the points for the foci. Now for the major and minor axes, I'm going to move them over here. So major axes is again 2 times a, so 2 times 5 is going to give me 10. And then for the minor, it's just going to be 2 times b, so 2 times 3 is going to be 6. Just barely fit that in there. And then the eccentricity is still going to be c over a. In this case, it's going to be 4 over 5. And now that we got all of that done, we can actually graph this. So center, 0, -5. So 2, 3, 4, 5 here. Vertices at -10 and 0. So 0, -10. And then the B value is 3. So from the center, we can go left and right 3 spots. So 1, 2, 3, and 1, 2, 3. And then connect the outer dots. So here, and here, and here, and there. Kind of like a diamond, but still should be an ellipse. So this is how you would do graphing a shifted ellipse, whether horizontal or vertical.